Determine delta y and dy for the function y equals the square root of x, where x equals 4 and delta x equals 17 over 16. Delta y equals y of x plus delta x minus y of x. For this problem, x is a 4 and delta x is a 17 over 16. So we have y of 4 plus 17 over 16 minus y of 4. We need to add the 4 plus the 17 over 16 through a common denominator. We will need to put the 4 over a denominator of 16 by multiplying it by 16 over 16, a form of 1. So delta y will equal to y of 4 times 16 is 64 over 16 plus 17 over 16 and then minus y of 4, which will give us y of 64 plus 17 is an 81 over 16 minus y of 4. So delta y can now be evaluated by plugging these x values into the function for y, which is the square root of x, giving the square root of 81 over 16 minus the square root of 4. The square root of 81 over 16 can be broken up into the square root of 81 over the square root of 16 minus the square root of 4, which is a 2. The square root of 81 is a 9. The square root of 16 is a 4, 9 over 4 minus 2. We will want to combine these together over a common denominator, so let's multiply the 2 by 4 over 4, a form of 1, to give the common denominator. We have 9 over 4, and then minus 2 times 4 is minus 8 over 4. 9 minus 8 is a 1 over the 4. There's our delta y. The next thing we want to determine here is going to be dy, and dy is found by taking the derivative of the function y. Y equals the square root of x here. Since we have to take the derivative, we will want to rewrite this as a fractional exponent. This is x to the first power, second root, x to the 1/2 power. When we take the derivative, we will want to use the dy dx notation. So dy dx will equal the power rule, bring the power down, leave the inside alone, and then subtract 1 from the power. I will call that 2/2. Then multiply by the derivative of the inside to complete the chain rule. The derivative of x is just a 1. 1 times 1/2 is a 1/2, and then x raised to the 1 minus 2, negative 1/2 power. Since it's a negative exponent, we can move it into the denominator with the 2 to make it a positive exponent. 1 over 2x to the positive 1/2 power. The positive 1/2 power can be rewritten as square root of x to the first power. So 1 over 2 square root of x. We will want to solve for dy by multiplying dx to the right side, so that dy equals 1 over 2 square root of x times dx, and we can replace dx with delta x to give it a value. 1 over 2 square root of x times delta x. We can now find dy by plugging numbers in, and that will give us 1 over 2 times the square root of 4 times the delta x, which is 17 over 16. So we have 1 over 2 times the square root of 4 is a 2, times 17 over 16. 1 over 2 times 2 is a 4, times 17 over 16. We can multiply the numerators. 1 times 17 is a 17 over, multiply the denominators, 4 times 16 is a 64. dy should closely approximate delta y in many circumstances. Delta y is a 1 over 4, which would be a 16 over 64. and dy is a 17 over 64, so it is closely approximating it here.